AI/ML model, detailed explanation of each node and audit brief. Pradeep K. Suri. Author, researcher, and AI/ML architect. 1. Design and development. Purpose: this is the initial phase where product specifications, requirements, and designs are created. Audit focus: verify design compliance with customer requirements and regulatory standards. Review intellectual property, IP, usage and licensing. Check the adequacy of simulation and modeling for functionality and performance. 2. Raw material procurement. Purpose: ensuring the availability and quality of raw materials, such as silicon wafers and chemicals. Audit focus: assess supplier qualification and contract terms. Validate material quality certifications. Check inventory levels and procurement lead times. 3. Wafer fabrication. Purpose: the process where raw silicon wafers are transformed into semiconductor chips. Audit focus: inspect the fabrication process for adherence to specifications. Monitor equipment calibration and maintenance records. Assess process efficiency and defect rates. 4. Etching. Purpose: removing specific material layers to create circuit patterns on the wafer. Audit focus: validate process precision and uniformity. Verify chemical usage and disposal methods. Ensure compliance with environmental safety standards. 5. Deposition. Purpose: adding thin material layers on the wafer surface, essential for creating circuits. Audit focus: check the uniformity of deposited layers. Inspect material usage efficiency. Evaluate the impact of deposition on wafer integrity. 6. Lithography. Purpose: using light to transfer circuit patterns onto the wafer. Audit focus: verify mask alignment and resolution. Review exposure equipment calibration. Monitor the rejection rate and rework frequency. 7. Wafer inspection. Purpose: quality checks for defects at various stages of fabrication. Audit focus: inspect defect detection methodologies. Analyze inspection equipment performance. Review defect classification and root cause analysis procedures. 8. Electrical testing. Purpose: ensuring each chip functions as designed by performing electrical tests on the wafer. Audit focus: validate testing parameters and methodologies. Check test yield and error rates. Review test equipment reliability and calibration. 9. Yield analysis. Purpose: analyzing the ratio of usable chips to the total chips produced on a wafer. Audit focus: review yield trends and improvement initiatives. Investigate factors contributing to low yield. Assess statistical process control, SPC, measures. 10. Packaging. Purpose: protecting chips and preparing them for shipment and use. Audit focus: check package material quality and assembly process. Verify package design for thermal and mechanical stress. Inspect labeling and traceability systems. 11. Final testing. Purpose: comprehensive testing of packaged chips to ensure performance and reliability. Audit focus: validate final test parameters and conditions. Review batch rejection rates and rework procedures. Inspect test data reporting and archival systems. 12. Distribution. Purpose: delivering finished semiconductor products to customers or market channels. Audit focus: verify logistics partners and distribution processes. Check packaging integrity during transit. Assess delivery timelines and customer satisfaction. 13. Customer engagement. Purpose: maintaining strong relationships with customers for feedback and future needs. Audit focus: review communication channels and response times. Analyze customer feedback integration into processes. Inspect support service performance metrics. 14. Feedback integration. Purpose: using customer and internal feedback to improve processes and products. Audit focus: validate feedback collection and analysis mechanisms. Assess the impact of feedback on product revisions. Monitor timelines for feedback implementation. 15. Sustainability. Purpose: ensuring environmentally friendly and sustainable practices throughout manufacturing. Audit focus. Inspect resource usage efficiency, example water, energy. Verify compliance with environmental laws and standards. Review waste management and recycling efforts. 16. Process monitoring. Purpose: continuous monitoring of production processes to ensure stability and quality. Audit focus. Validate real-time monitoring systems and alerts. Review historical process data for trends and anomalies. Inspect corrective and preventive actions taken for deviations. 17. Defect analysis. Purpose: investigating and addressing defects to reduce recurrence. Audit focus. Inspect defect classification and failure analysis reports. Assess corrective action effectiveness. Verify the use of advanced analytics or AI for defect prediction. 18. Supply chain management. Purpose: managing the flow of materials, information, and products effectively. Audit focus. Review supplier performance metrics. Inspect supply chain visibility and traceability. Validate risk management strategies for disruptions. 19. Regulatory compliance. Purpose: ensuring adherence to all industry regulations and standards. Audit focus. Verify compliance with international and regional standards, example ROHS, REACH. Review audit trails and certification documents. Inspect employee training on compliance requirements. 20. Market deployment. Purpose: launching semiconductor products into the market. Audit focus. Validate product readiness for deployment. Review marketing and sales strategies. Inspect after-sales support infrastructure. Each node represents a crucial step or aspect of the semiconductor manufacturing process, and auditing ensures quality, compliance, and efficiency throughout the product life cycle. 1. Design and development. Observations. 90% of designs comply with customer specifications. Minor delays observed in simulation test results for new architectures. Compliance status: partially compliant. Recommendations. Streamline design review timelines. Invest in faster simulation tools to minimize delays. 2. Raw material procurement. Observations. Supplier certifications were up to date. 5% variance in material quality in one batch, immediate replacement was arranged. Compliance status: compliant. Recommendations. Strengthen quality checks at supplier facilities to avoid recurrence. Automate supplier performance tracking for efficiency. 3. Wafer fabrication. Observations. Process steps documented and adhered to as per ISO standards. Equipment downtime reported 3 times, causing minor production delays. Compliance status: compliant. Recommendations. Implement predictive maintenance for key fabrication tools. Increase operator training on equipment handling. 4. Lithography. Observations. Mask alignment achieved a 98% success rate. 2 instances of incorrect exposure settings resulted in material wastage. Compliance status: partially compliant. Recommendations. Introduce automated exposure calibration systems. Enhance operator training programs. 5. Electrical testing. Observations. Test yield at 95%, exceeding industry benchmarks. Inconsistent reporting format for rejected units. Compliance status: compliant. Recommendations. Standardize reporting templates across testing stations. Introduce AI-based failure pattern recognition for test data. 6. Sustainability. Observations. Wastewater recycling achieved 85% efficiency. High electricity usage in wafer fabrication stage. Compliance status: partially compliant. Recommendations. Explore renewable energy options to reduce power consumption. Increase wastewater recycling to exceed 90% efficiency. 7. Process monitoring. Observations. Real-time monitoring systems operational and accurate. Alerts for deviations resolved within acceptable time limits. Compliance status: compliant. Recommendations. Expand predictive analytics capabilities for anomaly detection. Conduct quarterly reviews of process monitoring data for trends. 8. Regulatory compliance. Observations. 100% compliance with ROHS and REACH regulations. Employee training records updated as per requirements. Compliance status, fully compliant. Recommendations. Maintain the current compliance practices and focus on proactive risk assessments. 9. Customer engagement. Observations. Customer feedback response time averages 3 days. Limited documentation of customer feedback integration into designs. Compliance status, partially compliant. Recommendations. Reduce response time to 2 days. Implement a feedback tracking system to ensure actionability. Overall summary. Node compliance status observations recommendations. Design and development partially compliant simulation delays observed streamline review timelines. Raw material procurement compliant minor quality issue resolved strengthen supplier checks. Wafer fabrication compliant equipment downtime reported implement predictive maintenance. Lithography partially compliant incorrect exposure settings automate calibration. Electrical testing compliant inconsistent rejection reports standardize reporting templates. Sustainability partially compliant high electricity usage explore renewable energy options. Process monitoring compliant efficient real-time systems expand predictive analytics. Regulatory compliance fully compliant fully adheres to standards maintain practices. Customer engagement partially compliant delayed feedback integration reduce response times. Conclusion. Compliance rate, 85%. Key focus areas. Sustainability enhancements. Improved defect and yield analysis. Proactive customer engagement. Next steps. Address recommendations by the next audit cycle. Conduct employee training on highlighted process improvements. Prepared by Internal Audit Team. Date, November 19, 2024. This report provides a structured approach to documenting audit findings and recommendations for improvement. The code you've provided generates a bar chart displaying the audit cost breakdown and percentage contribution, with a dark-themed layout. The plotly.graph_objects library is used to create the figure, and the varieties color scale is applied to the bars to reflect the percentage of each cost. Here's a quick summary of the chart. 1. Labels and costs. The chart is using labels for different categories of costs, including total cost, design and development, raw material procurement, etc., along with their respective cost values. 2. Percentages. Each cost is shown with its corresponding percentage contribution to the total cost. 3. Layout. The chart is styled with a black background and white font to create a modern, dark-themed visualization. The bars' colors are based on their percentage values, and the color scale is shown on the side. The x-axis labels are tilted at 45 degrees for better readability, especially when dealing with longer text labels. This will display the chart in an interactive format, where hovering over the bars will show the cost in INR along with its percentage contribution. Key features. Interactive plot. The plot will be interactive, allowing you to hover over individual bars for more detailed information. Color scale. The colors of the bars are dynamically set based on the percentage contribution of each cost category. The diagram titled Audit Cost Breakdown, Pradeep K. Suri, AI/ML Architect, illustrates the costs associated with various stages of a project in the semiconductor industry, measured in Indian rupees, INR. Here's a detailed breakdown of each component. Key components and costs. 1. Total cost. Amount, 1 million Indian rupees. Significance, represents the overall expenditure for the entire project. 2. Design and development. Amount, 100,000 Indian rupees. Significance, covers expenses related to creating the blueprint and initial development. 3. Raw material procurement. Amount, 90,000 Indian rupees. Significance, costs associated with sourcing and acquiring raw materials needed for production. 4. Wafer fabrication. Amount, 80,000 Indian rupees. Significance, expenses incurred during the manufacturing of silicon wafers. 5. Etching. Amount, 70,000 Indian rupees. Significance, costs related to the etching process, which creates the intricate patterns on the wafers. 6. Deposition. Amount, 65,000 Indian rupees. Significance, involves expenses for depositing materials onto the wafer. 7. Lithography. Amount, 60,000 Indian rupees. Significance, costs for the lithography process, which transfers the circuit design onto the wafer. 8. Wafer inspection. Amount, 55,000 Indian rupees. Significance, expenses for inspecting wafers to ensure quality and detect defects. 9. Electrical testing. Amount, 50,000 Indian rupees. Significance, costs for testing the electrical functionality of the wafers. 10. Yield analysis. Amount, 45,000 Indian rupees. Significance, expenses related to analyzing production yield and efficiency. 11. Packaging. Amount, 40,000 Indian rupees. Significance, costs for packaging the finished semiconductor chips. 12. Final testing. Amount, 35,000 Indian rupees. Significance, expenses for conducting final quality tests before distribution. 13. Distribution. Amount, 30,000 Indian rupees. Significance, costs associated with distributing the finished products to customers or distribution centers. 14. Customer engagement. Amount, 25,000 Indian rupees. Significance, expenses for engaging with customers, gathering feedback, and providing support. 15. Feedback integration. Amount, 20,000 Indian rupees. Significance, costs for incorporating customer feedback into future production cycles. 16. Sustainability. Amount, 15,000 Indian rupees. Significance, expenses related to sustainable practices and environmental management. 17. Process monitoring. Amount, 10,000 Indian rupees. Significance, costs for monitoring the production process to ensure efficiency and quality. 18. Defect analysis. Amount, 5,000 Indian rupees. Significance, expenses for analyzing defects and implementing corrective measures. 19. Supply chain management. Amount, 3,000 Indian rupees. Significance, costs for managing the supply chain and logistics. 20. Regulatory compliance. Amount, 2,000 Indian rupees. Significance, expenses to ensure compliance with industry regulations and standards. 21. Market deployment. Amount, 1,000 Indian rupees. Significance, costs for deploying the products in the market. Summary. This bar chart provides a comprehensive breakdown of the various costs involved in the semiconductor manufacturing process, from design and development to market deployment. The total cost stands significantly higher than the individual components, emphasizing the cumulative nature of these expenses. This visual representation helps in understanding the distribution of costs and identifying key areas where resources are allocated. Thank you.